Hello and welcome everybody to this Azure Synapse Espresso. I'm joined here today by Liliam, which means we're going to talk about dedicated SQL pools. We've been talking a lot about the different distributions and how tables are created and all those things, but today we're going to dive in a bit into our first performance issue. Now, there's a thing called shuffle moving inside of a dedicated SQL pool. So my first question to you, Liliam, is what is shuffle moves?
Cool. So we are going deep now. Okay, so first, as we have already discussed, right, we are in a distributed database which use three patterns. And those three patterns, if you have doubts, just watch our latest or other videos about replicate, round robin, and hash. And those patterns that you're gonna divide the table across the distributions, it's when you create the table actually is when you define. So that's the first. So shuffle is a data movement. So it's an operation that does data movement. And why the data moves? Because for some reason, DW needs to redistribute the data across the nodes. Let me show you how that works. So here we have a select table A, table B, right? I wrote here on the side, you can see. Table A is distributed by A ID column. Table B is distributed by B key. So they don't have the same distribution keys. But when I'm doing the join, I'm doing A ID joining A ID from table B. So I'm doing the join between A and B, but not using the same distribution key. So what DW will do in that case? Because the distribution keys are different, you can see here, it will create temporarily table and redistribute that table by the distribution key of my join, and then do the join. And why the W does a thing like that? Because when the W is choosing the plans, we choose the one that's cheaper. And if, because I'm compatible join, which is this case here, if redistribute the table is cheaper to get the job done, it will do that. So putting SQL example, here we have the same scenario. Fact internet sales is distributed by product key, and this CTAS that I create later is distributed by sales order number. However, I'm doing the join by sales order number. And I'm using the option label, so I can easily find my query later. I will not run exactly this now because it takes 60 seconds. So once I run this, which is incompatible, I can find my query. So here goes, I can find my query. My query is QID 1048151, and here we go. And let's go with zoom again. And here you can see the shuffle move. So you're gonna see other operations here when you execute PDW request steps. And what I want with this is understand what is happening with my query. You have the random ID operation, which is basically just giving random name for a temporary object. You have an operation, it's executing an action on the database, and that does not matter for me. What I'm interested in is the shuffle move, which is a data movement. And what it's doing here is redistributing the data. And actually, you can see the commands that DW is executing in this part. And, oh, sorry, not very good with the zoom. And you can see the command that DW is executing this, and you realize that is in fact creating a temporary table and doing the hash per that column.
This is the actual plan, right? Is there a way to see the graphical plan as well, Liliam?
There is, okay, let's just go here.
Okay, and this looks very similar to like this looks very similar to what we have in a normal SQL server, right?
Yeah. So yes, this one it's more what we are used to, right? And you can see the shuffle happening here.
And it's also the biggest cost.
Yes, so you're gonna see the cost of 53, but still this was the less cost. This was the cheaper one. What would be the ideal in the scenarios would not have a redistribution of the data because of incompatible join. That would be the ideal, but we can explore this in future videos. Anyway, we see the cost of 53, which is the high cost, is still when the optimizer was executing the plan, this is the cheaper. Which the cheaper is still expensive, right?
Every shuffle move will basically create sort of a temp table in between, which means that if we have multiple incompatible joins, we'll create multiple shuffled tables, right? So each shuffle move, each join that we need to do to a table where we need to move data around, will create one of those tables. So it's each time a step for each join, right?
Yes, if you have multiple shuffle moves, you create multiple temporary tables for each shuffle move that you see, yes.
Awesome. So this basically means that a shuffle move is something that is introduced whenever we're doing an incompatible join. An incompatible join means that we have two tables distributed on a different key and they're not able to join locally on one of those nodes, which means we need to shuffle data around, move data around between these nodes to make sure that we can actually do that join together. A shuffle move then basically creates a new distributed table inside a temp table and joins with a temp table. Depending on how many joins you have and how many incompatible joins you have, you will have multiple shuffle moves to accommodate those join predicates that you've put in there. Now, how can you get around this? Very important. Choosing your distribution key well and making sure you have compatible joins between two larger tables, or for the smaller tables that you're joining, use replicated, which will be the data on all of these nodes, which we've seen in previous videos. In the next video, we'll be talking a bit about choosing those distribution keys and what to think about and what is good, what is bad. And that's about it. Now, if this is the first time you're visiting our channel and you've liked the content, just subscribe to the channel. If you like the video, give us a thumbs up. And if you have any other questions or if you have any requests for other videos or any comments, just write them in the comments and we'll definitely get back to you. As always, from the Synapse Espresso team, this is Stijn
And Liliam.
Thank you very much for watching and see you next time. Bye.
Bye.